Assalamu alaikum student. Now I will discuss structure of glucose. It's both open and closed form or cyclic form. When glucose that is in the form of crystals or in crystalline form, then it appears in open chain forms. Now open chain forms of glucose, they are of two types. One D form and other one is called as what? L form. Now student, keep this thing in your mind when in D form with carbon number 4 and carbon number 5 hydroxyl group is on the right side, is on the right side, while when it is in L form with carbon number 4 and 5 hydroxyl group is on the left side, now but when it dissolves in water in aqueous solution, it appears in cyclic form, and there are two cyclic forms of glucose. Either it is D glucose or L glucose, both have two cyclic form. They are alpha form and beta form or beta sugar. Now first of all I will write open chain forms. You can see this is carbon number 1, 2, 3, 4, 5 and 6, as it is a 6 carbon sugar. Carbon number 1, that is part of what? aldehyde group. 2, 3, 4, 5 and 6. Okay, this the last one, that will be CH2OH, as I explained already in ribose, and with carbon number 4 and 5 hydroxyl group, that will be on the right side. So obviously on the left side there will be what? Hydrogen. Now student, please memorize this thing, keep this thing in your mind, that when hydroxyl group with carbon number 4 and 5 that is on the right side, then with carbon number 2 its position that will be same, like hydroxyl group that will be on the right side and hydrogen that will be on the left side. So only one carbon that is left, so I will write here hydrogen and hydroxyl group. So this is what this is, D glucose. Now L form of glucose, when it appears in open chain form, that is what? That is, again it is an aldo sugar, C4, 5 and 6 carbon. Last one, that will be what? CH2OH, and with carbon number 4 and 5 I will write hydroxyl group on the left side and hydrogen on the right side. Then again same case, that will be with carbon number 2, that hydroxyl group that will be on the on the left side, sorry, and hydrogen that will be on the right side. And here I will write hydroxyl group and this is hydrogen. So this is what this is, L glucose or levorotatory. D glucose means dextrorotatory, and L glucose, that is what? Levorotatory. Now student, both D and L form, they are type of stereoisomers. Student, stereoisomers are those isomers which are having different arrangement of hydrogen and hydroxyl group in space. Now like you can see that here with carbon number 2 hydrogen that is on the right side, and in this you can see this is having what? Hydroxyl group on the right side and hydrogen on the left side. And same case with carbon number 4 and 5, that is there. So isomers are those molecules which are having same molecular formula but different arrangement of hydrogen and hydroxyl group. And stereoisomers are called as what? Like when they are having different arrangement of hydrogen and hydroxyl group in space. And Another thing which you have to keep in your mind, that these two, they are called as enantiomers. Enantiomers are type of stereoisomers which are mirror image of each other. Like you can see here hydroxyl group that is there, so here hydroxyl group, like they are a mirror image of each other, hydroxyl group, and this one is what hydrogen and hydrogen, but they are non-superimposable mirror image of each other. Like if I take this one and put it on this molecule d-glucose, then arrangement, then they will not give an effect of same molecule. Like here hydrogen that will be there, and here if I put it on it, here is what hydroxyl group. So that's why we say they are what non-superimposable, and enantiomers are non-superimposable stereoisomers. Now I can write it in cyclic form as well. Like both D and L glucose, they can be written in cyclic form to show them as enantiomers C C C. This is a structure which is called as what pyranose, and it has what 6 sides, 1 2 3 4 5 and 6, while in furanose, 5-sided structure that is formed as it was developed in case of what ribose, and this is a pyranose. So with carbon number 1, this is carbon number 1 2 3 4 5, and this is carbon number 6 CH2OH. Last one, okay, last one I will write on the over here. Okay, so here I will write hydrogen, then hydroxyl group, again hydrogen, hydroxyl group, then hydroxyl group and hydrogen, and then hydrogen and hydroxyl group. As on the top hydroxyl group that is already there, so I will write hydrogen over here. So this is what this is, d-glucose, it's d-glucose in cyclic form. So if I write another L-glucose, so that will be in this form, C C C C and this one. Okay, and now as I told you, in pyranosis, oxygen that makes a link between carbon number 1 and carbon number 5. So here this is carbon number 5, and this one is carbon number 1. Okay, and then this one is what, CH2OH. Okay, now this one hydrogen, hydroxyl group, then again hydrogen, hydroxyl group, then hydroxyl group and hydrogen, and last one is what, hydrogen and hydroxyl group. So this is carbon number 1 2 3 4 5, and this is carbon number 6. Again you can see they are not mirror image, they are mirror image of each other. This is what L-glucose, but they are not what superimposable, they are non-superimposable, so we call them what, enantiomers. Student, you can see that in this figure this is actually alpha D glucose, because hydroxyl group that with carbon number 1 that is in downward position, so it is what, it is alpha D glucose, and here with carbon number 1 again hydroxyl group that is in downward position, so it is also called as what, alpha L glucose. While when it is in beta form, at that time with carbon number 1, like you can write it in that upward position, and here it will be in downward position. Okay, then case will be different only with carbon number 1, not rest of the structure that will remain same, like hydrogen, hydroxyl group, again hydroxyl group, hydrogen, then hydrogen, hydroxyl group, and CH2OH, which is part of carbon number 6, and then here hydrogen that will be there. Now you can see that all the molecules, like with carbon number 1, you have to keep this thing in your mind that if it is alpha, then you have to write hydroxyl group in downward position, and if it is beta, like as it is beta D glucose, then you have to write hydroxyl group in the upward position with carbon number 1. Okay, this is 2, 3, 4, 5 and 6. Okay, now you can see that all the atoms which are on the left side, they are in upward position, and those which are on the right side, they are in downward position. Like with carbon number 2, you can see hydrogen is on the left side, then hydroxyl group that is on the left side with carbon number 3, then hydrogen that is on the left side, and so its position is what, upward, and those which are on the right side, they are in downward position. Like you can see, this is carbon number 2 hydroxyl group, then hydrogen, and then hydroxyl group. Last one, obviously, as and connection that is between carbon number 5 and 4, so arrangement that will be a different, and accordingly, and this is last one, carbon number 6. So obviously, if you are writing hydroxyl group on the top, definitely with carbon number 5 hydrogen, that will be in downward position. So it is a simple trick to learn that how hydrogen and hydroxyl group, they will be arranged around what, around carbon atoms in cyclic form. Okay, thank you, student.